All right, so I think this video is recording. Let's take a look at these two absolute value inequalities and solve them. Our first step is to get these absolute values by themselves. So in problem number 7, the first thing I'm going to do is subtract 9 from each side. So that gives me that the absolute value of 10 minus 8x is greater than, well, 11 minus 9 is 2. The absolute value is pointing, the arrow is pointing away from the absolute value. So I know that my shaded region is going to be away from the middle. It's going to be in the tails. Let's do two things. Let's drop three things. Let's drop the absolute value and write it as 10 minus 8x. Change the direction of the arrow and change the sign of positive 2 to negative 2. Now, this is creating a compound inequality, and for our second part, we simply drop the absolute value symbols and keep everything else the same. All right, so let's solve each one of these. On the left here, let's subtract 10 from each side. So we have negative 8 times x is less than, if I subtract 10, I get negative 12. If I divide both sides by a negative 8, dividing by a negative number, I'm going to have to change the direction of the inequality. Negative divided by negative is positive. 12 divided by 8 shares a common factor of 4. So that's 3 halves, right? All right, now let's look at this other one. Let's subtract 10 from each side. We've got negative 8x is greater than 2 minus 10 is a negative 8. If we divide both sides by a negative number, we have to change the direction of the inequality. And negative 8 divided by negative 8 is positive 1. So what do we have here? We have these critical points of 1 and 3 halves. That's an improper fraction. It's bigger than 1 because the numerator is bigger than the denominator. If you look at it as a decimal, that's 1.5. So that's to the right of 1. I'm not going to include these critical points, these endpoints in my solution set because the original inequality is a strict inequality. It does not say greater than or equal to. So I'm going to exclude that. X less than 1 means that I want to have the number shaded to the left of 1, and x greater than positive 3 halves means to the shade to the right. So now I have a picture of my solution set. I want to write that in interval notation. The left arrow is shaded, so that's negative infinity. We never have brackets around negative infinity or positive infinity. So from negative infinity all the way up to positive 1, any number that's in this interval will satisfy the original inequality, or if you're strictly bigger than 3 halves, that any number bigger than 3 halves will satisfy this absolute value inequality. So we're done with this problem. We've written our solution set using interval notation. Let's take a look at this number 8. Again, our first steps have to be to isolate the absolute value. So we need to subtract 3 from each side. So we've got negative 9 times the absolute value of x minus 10. That's greater than or equal to, if I subtract 3, negative 69 minus 3, I believe, is a negative 72. Now I have to divide both sides of this equation by a negative 9 to get the absolute value by itself. So I have the absolute value of x minus 10. When I divide by this negative number, the arrow changes direction, and negative 72 divided by a negative 9 is a positive 8. The arrow is pointing towards the absolute value. The middle portion of my number line is going to be shaded, not the tails, not like number 7. So I take positive 8, change it to negative 8, and drop the absolute value. And since I have my variable in the middle of these 3 portions, it's very easy to get that variable by itself. All I need to do is add 10 to all 3 portions here. So the idea is similar to balancing an equation. If I add 10, 10 minus 8 is 2. the negative 10 and positive 10 would cancel, and 10 plus 8 would be 18. So I claim that if you pick a number that is 2 or bigger than 2 yet smaller than 18, or if it is equal to 18, any of these numbers in between here will satisfy this original inequality. If you pick a number outside of this shaded region, it will not satisfy that inequality. To write my solution set here using integral notation, we write the smaller number, comma the larger number. Since we're including both endpoints, we use brackets. If you have questions, ask. Hope this helps, and I will talk to you later. Bye.